Hi everyone, this is Carlos with the Emacs Science Support Team, and today we are looking at Ldtk Limb Darkening Toolkit. Ldtk is a Python toolkit for calculating stellar limb darkening profiles and model-specific limb darkening coefficients using the Stellar Atmosphere Spectra library by Husser et al. 2013. So if you visit their GitHub, you will see a series of different notebooks to help us learn how to use the tool. We're going to jump into the example basics. So in this notebook, we are going to learn how to set up filters to use the LDPS set creator to create limb darkening profiles as instances of the LDP set class. And then with that, we are going to estimate limb darkening coefficients for the profiles and evaluate the limb darkening model likelihood directly from these profiles. So first thing we're going to do is we will import some of the things we will need just to visualize the text. And we are going to install a couple modules from Ldtk, such as LDPS set creator, boxcar filter, and tabulated filter. So these are different filters that we will use in our profile visualization. So first thing we're going to do, we will use the LDP set creator to essentially filter through our library and pull out specific spectra for some star. So here we're saying this is our effective temperature, log G, Z, our filters, and the data set. This may take a while to run as it can be a huge download or small. And then what we're going to do is we will use this sc.create_profiles and the number of samples to actually create the limb darkening profiles with their uncertainties for each filter. So what does that look like? Down here, we are visualizing the limb darkening profile. And when I zoom out, we can compare this G prime, R prime, T prime, Z prime to their profiles. This is what it looks like. As you can see, Z being pretty bright is showing us the most flux. Meanwhile, G being pretty dark is showing us the least flux. So we want to have some sort of precision here. So the next thing we're going to do is we will learn how to do limb darkening coefficient estimation. A couple ways we can do this. We can see all of our different options. So we have a linear model, quadratic model, square root model, nonlinear, general, triangular, power 2 model, and power 2 model with an alternative parameterization. So we're going to keep it simple. We will use a quadratic model. We will set QC and QE to this ps.coefficients_quadratic. And now here we are going to display that text. So these are our coefficients and their estimations. We want to double check that this is precise and our uncertainties are good. So we will use an MCMC. All you do is set do_MC equal to true, give the number of samples, and let it run. This is what we get back. These are our coefficients along with their uncertainties. Now we can decide that we don't trust the stellar model, and so we can set a multiplicative factor on the profile uncertainties, which we do here. Here we go, 2. Run it again, and these are our updated coefficients along with their uncertainties. Now we want to do a likelihood evaluation to see how true our model is. So this can be done for a single passband, like so, ps.ln_like_quadratic. Give your parameters. Then again, you can do it jointly for all passbands, as shown here, or in a parallel for a number of coefficient sets, which can be used when using population-based optimizer or MCMC samplers, such as EMCEE. So all we do again, use this ps.ln_like_quadratic, give it your sets, and you get back your value. So yeah, that is Ldtk Limb Darkening Toolkit. Really cool tool, fun and easy to use. I hope you guys enjoyed this tutorial. If you have any questions, comments, or concerns, follow us at Twitter at ExoPlanetModels or comment below. Thanks. Peace.